Okay, this is a Venn diagram of the numbering systems. Most numbers are real numbers. There is also imaginary numbers. An imaginary number is the square root of a negative, such as the square root of -1. What number times itself is a negative? There isn't any. That's why it's called imaginary. That's why you call it an I. So the square root of -1 is I. And those would be pure imaginary numbers. Inside the reals, you have integers, well, you have rationals and irrationals. Then you have the integers, the wholes, and the counting or the natural numbers. We're not going to get too much into separating them, but I do need you to know that complex numbers are written with a real component plus an imaginary component. So if you ever want to express a complex number properly, it should be an A plus BI form. Okay, as I told you before, you're going to need conjugates to rationalize. Now with complex numbers, you have something called the complex conjugates. First, your main conjugates. A squared minus B squared will factor into A plus B times A minus B. These again are called conjugates. Now, if you ever run into a form that is in A squared plus B squared, that's going to be involving something called complex conjugates. A plus BI times A minus BI. Again, I is the square root of -1. So these two things right here, I can tell you, can be extremely helpful. This is called complex conjugates. The only other thing that you might need to know are your 4 powers of I. I is the square root of -1. I squared, therefore, would be -1. I to the third is -I, and I to the fourth is a +1. After that, they start to repeat. For example, I don't think they're going to ask this in here, but could you tell me what I to the 27th is? I always break it up into I to the fourths. Does 4 go into 27? 6 times. 6 times 4 is 24. And if you added one more, because when you multiply, you add exponents, 24 times I to the first would still, I'm sorry, it goes in there more than that. How many times it go in? It leaves how many left over? 3, doesn't it? 24 and 3 add to 27. So what is this? Let's erase just one little part here. What is I to the fourth? 1. 1 to the 6 is just 1. What's I to the third? -I. So this would simplify to just -I. I don't believe we're doing the powers of I in this, but I guarantee we're going to use the conjugates in some of this. Okay, I truly hope that you don't make these more difficult than you have to. You do them just like the previous section, but if you're taking a square root of a negative, you just put an I in front of the radical. That's all you do. To get rid of a square, you take the square root. So you have x now. You have the square root of -1 times how it goes into 28. Does 4 go into 28? 4 times 7, right? So the square root of -1 is your I. The square root of 4 is your 2. And you have your radical 7. So most people will write it this way, 2i radical 7. Don't forget that it should have a plus or minus if you take the square root in an equation. So again, I really hope you're not making it harder than you have to, because all you do, first off, in number 5, opposite of adding 8 is to subtract 8. Now the only thing is you take the square root of a negative 4. The square root of 4 is 2. Because it's negative, you put an I. So that's pretty much it. You just do it just like you did in the previous section, but you might have to put an I. To get rid of a square, you take the square root. This could be square root of negative 1 times square root of 4, which is I times 2, or 2i. But again, plus or minus. Number 7, opposite of adding 31, subtract 31. That makes 2x squared plus 0 equal negative, what would this be? So I think if I subtract is negative 22. Opposite of multiplying by 2 would be to divide by 2. That would give me x squared equals negative 11. When you take the square root of a negative, just put the I outside. That's all you got to do. So this is going to be plus or minus I with the square root of 11. After 3, 5, and 7, we might come to 9. Group all your variables on the same side. It's called isolating the variable, just like in Algebra 1. If I do this, I should isolate the variable in one step. Those cancel and those cancel. So what do I end up with? 4t squared equals, I believe, negative 4. The opposite of multiplying by 4 would be to divide by 4, making t squared equals negative 1. To get rid of a square, we will take the square root. And the square root of negative 1 is I. But again, we need a plus or minus because we're dealing with it in an equation. After 9, we might have one like 13. These are very, very easy. Just treat I as a variable. Treat it like an x. What's 9 plus 8? What's 8i and a negative 9i? Any questions there? Again, you want it in the form of a plus bi. Now, b might be a negative 1. That's fine. But you want the real number, then the imaginary part. So if it says to add them, you just add them. Number 15 says to subtract them, so you just subtract them. I subtract by distributing the negative, which changes those two last signs. So let's do the reals first. What's negative 1 and negative 7? Negative 8. What's a positive I, 1i, and a 5i? Hopefully a 6i. And again, you should have your real number first and followed by your imaginary number. Okay, we're going to keep moving. We did an addition, we did a subtraction. Looks like now we're going to do multiplication. Negative I times 4 is negative 4i. A negative times a negative is a positive, and it would be 8, and I times I is I squared. If I haven't told you before, you do need to know that I squared is negative 1. So this I squared I'm going to call a negative 1 because that's what I squared is. So you have negative 4i minus 8. You're supposed to put your real first, followed by your imaginary, because that puts it into a plus bi, or standard form of a complex number. I is the square root of negative 1, therefore I squared is negative 1, which is what I did in this problem. 25 I'm going to distribute. Negative 2 times negative 1 is a positive 2. Negative 2 times 4i is negative 8i. 5i times negative 1 is negative 5i. And 5i times 4i is 20i squared. Now, can you combine negative 8i and a negative 5i to get negative 13i? Do you know that I squared is negative 1? So you have, let's see what we have here. We have 2 minus 13i and I think minus 20, right? Combine your reals first. 2 and a negative 20 is negative 18, and then you have the minus 13i. Again, you want the real number, real part, and then the imaginary part. And I figured I'd do one last one, like 29, maybe 31 or 33. 29 has a binomial in the denominator with an I. I is the square root of negative 1. You are not allowed to leave square roots in the denominator, which means you can't leave an I in the denominator. So I have to use a complex conjugate. I have a minus bi. Its complex conjugate would be a plus bi. When you multiply these, it becomes a squared plus b squared. It's like the difference of the squares, but it's with the imaginaries, and it becomes a plus, pretty much. So what's the conjugate here? The conjugate of 3 minus I would be 3 plus I. 3 plus I. On top, if you distribute 6i times 3 is 18i. 6i times I is 6i squared. I've told you that I squared is negative 1. So could this be 18i and 6 times negative 1, or minus 6? Because you're replacing that I, I'll go ahead and write it out. You're replacing that I squared with a negative 1. So in the numerator, you end up with negative 6 plus 18i. I could factor. If you wanted, I could take a 6 out of those. But let's see if we have to. In the denominator, you should have a squared plus b squared. So if this is a, if a is 3, what's a squared? 9. Plus is part of the symbol on complex conjugates. B is a 1. What's b squared? 1 squared would be 1. So pretty much this is divided by 10. You could factor a 2 out, or you could do half of everything that you see. And I would imagine this is how we'd leave the result. Because we do not have an I in the denominator, I think that would look good. I apologize, I have violated my own rule. We did not write this in a plus bi form. This is negative 3 divided by 5, and the 9i is also divided by 5. So the better way of writing it, or the proper way of writing it, would be in standard form for complex, a plus bi. Okay, I think 31 is actually easier because you simply have a monomial on the bottom. If I multiplied by a fancy form of 1i over I, on top I would have 4i plus 9i squared. I'm hoping you're getting to notice that I squared has to be replaced with a negative 1. So that's 4i minus 9, or negative 9 plus 4i. Anyway, that's just the numerator. The denominator, you just multiply, you get 12i squared. I squared is again negative 1, so that makes this negative 12. Let's see, I don't think it simplifies, but I have a negative 9 plus 4i, and they're both divided by negative 12, right? So a negative divided by a negative is a positive. 3 goes into there, 9 3 times. 3 goes into 12 4 times. And looks to me like if I'm divided by a negative, that'd be a minus I over, how many times does 4 go into 12? So something like this, they might call it a 1/3 I.